This YouTube channel has 1.5 million subscribers from just 51 videos and makes over $14,000 a month. Here's another, only 33 uploads, 2.8 million subscribers, and it's pulling in over $50,000 every single month. Believe it or not, these videos are created entirely with AI, and that's exactly what I'm going to show you today. I'll walk you through step by step how to build your own channel using an AI-powered system I built myself. It generates and uploads YouTube Shorts for you every hour, hands-free, no code needed. For example, I managed to create this video with just the click of a button. Just a few minutes of work, all done with the AI system I built.
Ollie the otter and playful otter friends eagerly gather colorful snacks under the warm sun by the sparkling riverbank, their excitement bubbling in the air. As the otters spread out a bright picnic blanket, Ollie clutches a tasty treat, eyes shining with anticipation amidst laughter and chatter. Ollie notices a shy otter watching nearby, hesitating to join. Inspired by kindness, Ollie offers a tasty snack with a warm smile. The shy otter smiles back, happily accepting the snack, and soon all the otters share food and stories, their joy multiplying together. Under the golden sunlight, Ollie feels a warm glow of happiness, learning that sharing snacks has made friends and filled hearts with joy.
Before we get started, I've made a checklist you can use to follow along and save yourself time. To make this as easy as possible, I've collected all the prompts and tools we'll be using on a single page in our community. I've even created a special blueprint file. Just download it, import it into the tool, and the entire workflow builds itself. No manual setup required. The link's right at the top of the description. Make sure to grab that before you keep watching. If you stick around until the end of the video, I'll even give you the templates you need to create any kind of video you want. And if you're worried about the tech side, don't be. This tool is completely no code. It's easy to learn, even for absolute beginners. If you know how to drag and drop, you're good to go. Honestly, learning AI automation right now is one of the smartest investments of your time. The demand is exploding. Just check Google Trends if you need proof. So if you give me the next few minutes and watch all the way through, you could be picking up one of the most valuable skills out there. The framework for what we'll be learning is actually pretty simple. You can break it down into 3 steps. First, we'll start by generating high-quality prompts using the initial row of nodes. Next, step 2 through 7 are all about editing, polishing your visuals, scripts, and audio. Finally, in step 8 we'll set up auto-publishing. That means your videos can automatically post to YouTube or any other social channel you choose. And don't worry, this last part is totally optional. You can automate everything or just the steps you want. To get started, the tool we'll be using is called N8N. Just click the link in our community to go straight to N8N's sign-up page. You can get a free trial or choose the self-hosted option and get 20% off, which is what I personally use. If you haven't heard of N8N before, think of it like Zapier or Make.com. The difference is N8N has been growing fast lately. Just check Google Trends because it's super flexible, especially for working with AI systems like the ones we'll be using here. And honestly, it's not complicated, especially when you have someone walking you through it step by step like in this tutorial. Now, if you look at our automation workflow, it might seem complex at first, but it's actually pretty straightforward once you break it down. The framework is simple. Starting at the top, the first nodes make up the input section. Here we have 3 AI agents. One generates ideas, another writes the story, and the third creates image prompts. All of that gets passed along to the next step. Let's take a closer look at the Ideas AI agent. This is one of the most popular nodes in N8N because it lets you configure an agent right inside this no-code tool. If we open it up, you'll see a lot of information, but don't worry. If you're new to N8N, it's helpful to step back and look at how every node works. Almost every N8N node follows a similar design. There are basically 3 regions. On the left is the input area, which contains all the data and information coming from previous nodes, basically everything being passed to this specific node. In the middle, the blue area, is where you configure your specific node. Using both the incoming information and your settings, the node then produces an output, which you'll see in the red area on the right. That output gets passed along to the following nodes in your workflow. So, if we go back to our very first node, the Ideas AI agent, you'll notice the input on the left is just a few attributes coming from the schedule trigger, the previous node. Then, in the middle, we have the configuration for this agent, which we'll dig into in a bit. Now, what the Ideas AI agent does is simple. It gives us a unique idea for our kid's story. This includes the title, the story idea itself, the character type, the lesson, the relationship dynamic, the character's name, and the setting, which will be used for both image and video generation. It also generates a short sound prompt for sound effects, as well as a production status. Every AI agent is set up in a similar way. There's a user prompt, which you can think of as a message you send to the agent, just like chatting with ChatGPT. If you look at it here, it's straightforward. It's a command to generate an idea for a specific niche, in this case the kids' cartoon niche we want to replicate. In addition to the user prompt, each AI agent has a system prompt. If you expand that section, you'll see the system prompt outlines the AI agent's role and a set of rules to make sure its output matches what we want. You can read through or tweak it as you like, but the key point is that the system prompt keeps the agent focused and consistent with your goal. Once the idea is generated for this run of our automation, you can simply click away, and you'll see that the output is ready to be used in the next steps. Next, we have the Story AI agent. Its job is to take the idea from the previous step and break it down into individual scenes for our story. If you look at the output here, you'll see it has generated 5 scenes. It uses the story idea, character type, environment, lesson, relationship dynamic, and character name, all of which are dynamically pulled from the idea's AI agent. For example, if I delete story idea from this prompt, I can simply drag and drop it again from the idea's AI agent's output in the input section. Like the idea's agent, the story AI agent also has a system prompt. This defines its specific role and keeps its output focused on what we need for the next stage. Finally, we have the image prompt AI agent. Its job is to take those story scenes and generate detailed prompts for images based on each scene. If we open it up, you'll see there's a simple user prompt. When you maximize it, you'll notice it basically tells the agent it will receive a story and an environment description for each scene. We pass along the story idea and the scenes to guide it on the setting for our character, but even more important is the system prompt. If I expand the system prompt, you'll see it's specifically designed for generating high-quality cartoon images. You can edit this as needed, but it provides clear instructions for the essentials the final prompt should include. This way, every time we call the image model, we automatically pass along a detailed and well-structured prompt. The output here is a solid, detailed prompt that not only follows our rules but also captures the fresh idea generated by our previous AI agents. This marks the end goal for this first row of nodes. Once you have your final image prompt generated, you're ready to pass it along to the next steps in your workflow. Now we need to log our data. This next node is just a simple Google Sheets node, and it's important because once you've generated your idea, you'll want to save it somewhere so you don't lose track of it. The setup for this Google Sheet is straightforward. I have it connected to a document called F3 Demo. If you open up that Google Sheet, you'll see it's just a basic spreadsheet with columns for our idea, caption, production status, scenes, and the image prompts we generated earlier. It's good practice to log each generation, so when the workflow finishes creating the final video, the automation can mark that row as done. This way, your Google Sheet serves as a tracker for all your ideas, image prompts, and video generations. Back in N8N, you'll see that each of those columns is mapped to the corresponding data coming from our idea's AI agent. For example, if I remove the idea value in the configuration, I can just drag it in from the input section again. You'll see a preview of the data at the bottom, showing how each column is mapped. The only exception is the final output column, which will store the finished video once the workflow is done. You might also notice the ID column is filled with an Excel formula. That's by design. When the Google Sheets node runs, it stores that formula, which generates a unique ID for each entry. You can also see that all the values created by our AI agents have been saved in the right columns. That's the purpose of the Google Sheets node, to keep everything organized and track each step of the process. Now let's move on to the next part of the workflow. If we keep following the workflow, the next node is called List Image Prompts, and its job is pretty simple. It takes the 3 scene prompts we have in the input section, which N8N groups as a single item by default, and splits or unbundles them into individual items. This step is important because once they're separated, you can pass each image prompt along one by one to the next node. That way you can generate individual images for each scene prompt, instead of trying to process them all together. The configuration for this node uses a bit of custom code, but don't worry, you don't have to write it yourself. You can just copy and paste it from my example here, or grab it from our community resources. Now we have our scene prompts separated into 5 individual items. That sets us up perfectly for the next step, where we generate the actual images. Now that our prompts are separated into 5 items, we can move to the next node. If you open it up, you'll see its purpose is to create images using the Flux model. If you haven't used this node before, it's actually just an HTTP request node, one of the most common and useful nodes in N8N. It's how you connect to third-party tools like Flux from inside N8N. Here's how it's configured. The method is set to post, since we're sending a request for Flux to generate images for us. Think of it like sending a letter, you need a destination address. Here, the URL is that address. For this workflow, we're using the Flux model via wavesp.ai. Wavesp.ai acts like an app store for AI models. Instead of visiting each model's website and learning a different API every time, you just use one platform. They aggregate a bunch of AI video and image generation models, so it's much simpler. There are a few versions of the Flux model available, but I'm using this one because it's the most affordable. If you click on the API tab on WaveSpeed, you'll get all the info you need for a post request. The URL I pasted into N8N comes straight from that section in WaveSpeed. Since we're sending a request, the body section is where you tell WaveSpeed what you want. Here's how it works. Size is set to 578 by 1024, which is perfect for vertical images. Prompt is dynamic. It pulls in the theme, the main action from our AI agent, and a description of the environment, all bundled together. When the workflow runs, these are the instructions sent to WaveSpeed. You can click the arrow in N8N to see all 5 prompts, since we're generating 5 images. In the output, you'll see 5 items, each with a status code of 200, which means success in API terms. If you run into a credential error here, it probably means you haven't set up your WaveSpeed credentials correctly. In N8N, open the node settings and click the pen icon to edit credentials. You'll need 2 things. The name, which should be authorization, just like in the WaveSpeed docs. The value, which is bearer followed by your API key. You can find this in your WaveSpeed dashboard under Access Keys. Set this up once and you can reuse it for other nodes and workflows. Finally, when you check the output of this node, you'll notice you don't see the images yet. That's normal. A status code of 200 just means the request was received. Flux is still working on generating the images in the background. The next node is just a simple wait node. If you open it up, you'll see we're literally just waiting 540 seconds for Flux to generate our images. That's all it does, gives Flux enough time to finish before we continue. Once the wait is over, we move to the next HTTP request node. This node's job is to fetch the images we just generated. The method is set to GET, and the address is based on WaveSpeed's documentation. The only difference is that we include a dynamic value in the URL, so it points directly to our specific job. When you check the output, you'll see it lists all 5 generations we created with WaveSpeed. We use the same WaveSpeed credentials for this node as before. Once it runs successfully, you'll get 5 outputs, each with a URL ending in .jpg. You can copy and paste any of those URLs into your browser to download or preview the images. For example, here's the very first image we generated. So if we dive into step 3, you'll see this is another HTTP request node. By now, this should look familiar. We're once again posting a request, but this time it's to automate turning our images into video clips. For this, we're using a model called Cdance V1 Lite 480p from ByteDance. This model takes the images we generated and converts them into video clips at a very low cost. As before, we use a WaveSpeed URL to send our request. Scroll down to the body section. This is where you tell WaveSpeed exactly what you want. Aspect ratio is set to 9:16, perfect for vertical videos. Duration is set to 10 seconds. Images are dynamic and come from the earlier image nodes. Prompt is dynamic as well, combining the video theme, the main action from our AI agent, and a description of the environment. When the workflow runs, these specs get sent to WaveSpeed. In the output, you'll see 5 items, each with a status code of 200, which means the request was successful. The next node is a simple wait node. If you open it, you'll see we're just waiting 600 seconds for Cdance to generate our videos. Once that time has passed, we move on to the next HTTP request node. This final HTTP request node in the chain has one job: to fetch the video clips Cdance just created. The method is set to GET, and the address comes from WaveSpeed's documentation. But this time it uses a dynamic value, so it points to the results of our specific job. When you check the output, you'll see it lists all the generated videos. You can open those URLs to download or preview your finished video clips. At this point, we've used Cdance to generate some video clips. Now, the next steps are about adding sound effects, captions, and stitching everything together so you have a longer, complete video. Let's look at how to add sound effects first. In step 2 here, we use another HTTP request node, this time to create sound layers for our video clips. The model we're using is called Audio, which takes a video clip and adds sound effects on top, all at a very low cost. As with the previous steps, we're sending this request through WaveSpeed. If you open the body of the request, it's pretty straightforward. There's a guiding prompt for the type of sound. Here I've just used ASMR soothing sound effects, since that fits our niche. You can change or delete this as needed. There's a dynamic value for the sound coming from our prompt's AI agent, so each clip can get unique effects. Duration is set to 10 seconds for each clip. Most importantly, the video URL field pulls in the MP4 URL from the previous node, so we're sending the video clips we just created. When this node runs, you'll see the output indicates the requests are now queued. That means Audio is busy layering sound onto those clips. After that, we add a wait node. This one is set for 60 seconds just to give Audio enough time to process the files. Next, we use another GET request to retrieve the finished clips. The URL for Audio here uses a dynamic request ID to track and pull down the correct files. When you check the output, you'll see items for each video that now has sounds added. You can copy any of these URLs, paste them into your browser, and download the files to preview, with the new sound effects in place. Audio is also extremely cheap, so this workflow remains budget-friendly even as you scale up. Now that we've generated our videos and layered on sound effects, it's time to add voiceovers. Let's move to step 5. We start by unbundling the scenes that were generated by the Story AI agent. This is done with a simple code node, just like we did earlier with image prompts. The code breaks the scenes apart so we can send each one individually to 11 Labs for voice generation. You can copy this code from our community resources. Next, we connect to the 11 Labs node. Here's what you need to do. Make sure you've set up your API credentials for 11 Labs and N8N. If you don't have an account, just follow the link in the video description or in our community and sign up. Once you're in 11 Labs, click your name, go to API keys, and generate a new API key. Give it a name, click Create API Key, and make sure it has access to text-to-speech models and voices. Head back to N8N, add your API key to the credentials and save it. In the 11 Labs node, under Resource, select Speech. Under Operation, choose Text-to-Speech. Pick the voice you want from your saved voices. If you haven't saved any voices yet, go back to 11 Labs, add the voices you like, then refresh N8N to see your options. Drag each scene from the unbundled list into the text input for the node. Execute the node. 11 Labs will process each scene and output the audio files. You'll see these appear on the left in the output section. Now, we need to upload these audio files to Google Drive so we can link to them in the next step. Create a folder in Google Drive for your voiceover files. In N8N, add a Google Drive node and authorize it using the same process as before. Sign in and connect your credentials. Set the resource to File and the operation to Upload. You can leave the input file name as Data, and N8N will use the original name from 11 Labs. Select the folder you just created as the parent directory. Execute the node and you'll see the files uploaded. N8N will display the file IDs and web links for each upload. Now that we've created our videos, added sound effects, and generated our voiceovers with 11 Labs, it's time to stitch everything together. Step 6. Stitching the voiceovers and clips. First, we use a code node to extract the IDs of our audio files from Google Drive. The purpose here is to list out those IDs because we'll need them in the next steps. Next, we add a set node, one for videos and one for audio. For the video set node, we use manual mode to map each video URL into its own field, video_1, video_2, etc. This makes it easy to keep track of each part for later merging. For the audio set node, we do something similar, but here we use direct Google Drive links so our video editor can access them. Just copy the IDs into the template and you'll be set. Repeat this process for each audio file, ensuring everything is lined up in order. Now we use a merge node. Set it to append mode with 2 inputs, so it outputs a single combined list where each video and its matching audio are paired together. After merging, another code node matches each video URL with its corresponding audio/voiceover. The output is a tidy table. Video_1 with audio_1, video_2 with audio_2, and so on. With everything paired up, it's time to send these assets to your video editor. You can use a self-hosted service like the one in our community guide, JSON2video file.ai, or any tool that wraps FFmpeg and exposes an HTTP API. In your JSON script, used in an HTTP request node, just paste the URLs of your video and audio files in the required format. This step initiates the stitching process, combining video and audio into a single clip for each scene. When you send the request, you'll get a status code of 200 received or 202 processing. The workflow checks job status, waits if it's not done, and loops back until everything is complete. When done, the editor returns URLs for your finished clips. Now, you want to stitch all the clips into one complete video. Again, use a code node to unbundle the final scene clips. Then, send those URLs to your video editing API using another HTTP request node. This time, the action is to concatenate, combine all your scene videos into a single file. You can do this with any tool that offers a concatenate or similar function, just like FFmpeg does, adding captions. If your editor supports it, like our self-hosted setup, you can also add captions at this stage. Just include your caption settings, color, font, size, style, position, etc. in the API call. This gives you total control over how your captions look. Final steps: logging and publishing. Once your final MP4 file is ready, the workflow checks if it's complete. When done, it logs the output and changes the production status to done in your tracking spreadsheet. Now that we've concatenated all the video clips and have our finished video, it's time for the final step: publishing to socials. For this step, we'll use a tool called BlotAuto, a social media publishing platform that gives you an API key for automating your posts. With BlotAuto, you can publish directly to X, Twitter, LinkedIn, Facebook, TikTok, Instagram, Threads, Pinterest, and YouTube. You can even connect over 20 different social accounts with just one BlotAuto account. Link your social profiles to BlotAuto. Once connected, copy the account IDs for the platforms you want to publish to. For this demo, I'll use my YouTube account ID. Create a set node in your workflow. Here, just list the account IDs you copied from BlotAuto. This helps N8N know which social platforms to send your video to. Upload your video to BlotAuto. Add an HTTP request node. Set the method to post. Use this URL. For authentication, choose generic credential type and create new credentials. In the name field, enter BlotAuto API key. In the value field, paste the API key you copied earlier. In the request body, select JSON. Set the field to URL and paste in the URL of your final video. You can pull this from the previous step in your workflow. Click Execute. If successful, your video will upload to BlotAuto. Prepare your post details. Create another set node to structure the payload for publishing. Set the platform, e.g. YouTube, the account ID, the video URL, the title, and any other fields you need, privacy status, content type, etc. Post your video. Add another HTTP request node. Set the method to post. URL this URL. Use your BlotAuto API credentials. In the body, structure your JSON to include the target platform, account ID, video title, privacy status, set to unlisted for testing or public for live, and media URLs. Check your results. When you execute this node, you should get a success response. Head over to YouTube or your chosen platform to verify your video is live. And that's it. You've fully automated your video publishing process across multiple social platforms. If you run into any errors, leave a comment or join our community for troubleshooting and support. Thanks for following along.